Good morning. My name is Abhay Chawda and I'm here to explain my master's project. So for my master's topic, I've chosen customization of operating systems. I've done one application and one research mini project on it. So for the application, I've chosen to build a custom command line interpreter. So the first thing I wanted to do in that was like when a signal comes, suppose sig terminate comes via control C, then instead of terminating the program, it should do something else. It should print history. So I did that using signal handlers in C, and what it did was like I used execv system call to like run another process, child process, which will hold all the, it will go to the bin and read the history and print it out. So that was the first task, and then I thought like how to scale this up, how to build my own fully custom command line interpreter. So for that I wrote a code which will run a program indefinitely, and you can type the common Linux commands like ls, pwd, man and all that, and it will every time the thing that is it does is same, it will run an execv command and it will generate a new child process, and that process, suppose you want to do a ls, then it will go to the directory and it will read the contents from the process table and it will return that. So that's how I built the custom command line interpreter. Then for the second one, I wanted to see how we can generate our own signal. So that was the research project, mini project. So in that I wanted to figure out how to build our own signal. So usual signals are there, sig env, sig term, sig alrm. So like that I wanted to build my own signal. So the two ways of doing that. One, either like signals are basically just numbers which are notifications that the kernel gives to the user process, like it gives this number and then the process maps it like this number means this notification, and according to the signal handler it takes the action. If there's no signal handler provided, it uses the default signal handlers that C provides. So I didn't want to just use signal handlers, I wanted it to do something completely different, like suppose from 1 to x the numbers are there for signals, then I wanted to make an x plus 1 signal that it will be able to recognize like sig abhay or something. So for that I tried to do that, but then I realized very quickly that that's not possible because the kernel blocks us from doing that, because it's in the kernel space, like which all signals exist and all that. So I tried to figure out different ways to get around this. So one was like a kill process. So if the permissions are not properly allocated, then another process can send any kill signal, like when the other process is not expecting a signal, you can just send a signal prematurely or just the wrong signal, and we can cause unexpected behavior to happen. Means like the process itself was not and the user was not expecting that behavior, but we can cause it to happen by using the kill process. So that was the first one. The second one was the classic dirty read write thing. So one system call happens, and before the other system call can happen, we can send another signal. We can make a signal handler send another signal there that will sorry wait yeah, what happens is between the fork and exec, suppose fork and exec system call, it was not expecting another signal, and it has not built a signal handler like at that point it should not expect any signals. Then at that point we can insert a signal and cause undefined behavior. So at that point it might misinterpret the signal. Like even if we give one signal, it might misinterpret as another signal, because at that point it was not expecting any signal at all. So that's the second method, the dirty read write problem. The first one was using kill with permissions. So the third method was making it misinterpret the numbers. Like suppose one was supposed to go, then we somehow get it to send another number. So that part requires a lot more of research and all that, because it's not even freely available on the internet, because it goes into the cyber security domain, and that information is usually guarded. So basically these three things I was able to research on, these three topics, mostly the first two topics, but even the third one, and I've generated documentation about it, and the first command line interpreter, it's the application based part, and I've created a custom command line interpreter with a lot of the common utilities, and I've attached the code file as well, and I've also written a documentation report on that as well. And so yeah, that's it. The application part was one, the custom command line interpreter, and then the research part was another part. These two together comprise my master's project. Okay, thank you.